Well, hello everyone. We are in the unit for deductive reasoning. Deductive reasoning is a type of reasoning where you use facts, postulates, definitions, and put together to come to some valid conclusion. We have two laws that we study with deductive reasoning, and one of them is the law of syllogism, which we've already dealt with. And the other one is the topic of this little lecture, which is the law of detachment. The law of detachment works if you start with a true conditional. Remember, a conditional is a statement that can be written in if-then form. If you start with a true conditional and you look at a situation, a different situation, and the hypothesis of the conditional applies and is true, then you can conclude that the conclusion is true. It is safe to say that the conclusion is true. All right, it might help to maybe look at some examples like that, but as in symbols, if P implies Q and P is true, then Q is true. Now we have this statement, and we'll just follow these examples.
For anyone that is still in the building here right now, the great and wonderful Mr. Dakin has decided to cancel school for us for tomorrow, so enjoy your day off.
You know what? I think I'll leave that on there. I'm not going to redo that. Our esteemed Mr. Bennett, our principal, has just announced that we are not going to school tomorrow, but I'm going to finish this video for you. And you can watch it tomorrow and then aim to be ready for everything on Wednesday. Okay, back to the topic. If two angles are complementary to the same angle, then the angles are congruent.
Thank you for that information, a great and powerful Oz.
All right. And we've got comedians on staff too. If two angles are complementary to the same angle, then the angles are congruent. All right, you have a hypothesis and a conclusion. You have a conditional that is true. This is a true and postulate theorem in geometry. If two angles are complementary, two angles add up to 90 degrees. Is complementary angle. If two different angles are complementary to the same angle, they have got to be the same measure. All right, well, let's look at the hypothesis here. Angle A and angle C are complementary to angle B. Is that saying two angles are complementary to the same angle? Angle A, angle C, two angles complementary to the same angle B. So yes, it is saying that. Now your conclusion here says angle A is congruent to angle C. Now, is that valid? Well, it says the angles are congruent, so yes, that is valid. This conclusion is valid by the law of detachment. Now, number two has a problem. First of all, what you are given needs to be the hypothesis of your valid conclusion. Well, what are you given? You're not given the hypothesis. You are given the conclusion. And then you can't just go backwards like that. It doesn't necessarily work in reverse. It says angle A is congruent to angle C. I can't conclude that angle A and angle C are complements of angle B. I don't know what angle B is. I don't know if angle A and angle C are too big or whatever. So that is invalid. And it is invalid because the conclusion is given, not the hypothesis. You need to start with the hypothesis. All right, well, let's look what this third one does. Angle E and angle F are complementary to angle G. Their conclusion. Now, I think that matches. We got two angles that are complementary to the same angle. That matches the two angles are complementary to the same angle that we had up here. Well, so we're okay. The conclusion is angle E and angle F are vertical angles. The conclusion needs to be angle E and angle F are congruent. That's the only thing from this statement that you can conclude. All right, so it's invalid. Because the conclusion is wrong. So I'll just write invalid, wrong conclusion. Okay, let's look at our time here. I think we've got time to look at a couple more. And I'll turn the paper over. And here's what we're to do here. It says determine whether statement 3, the third statement, follows from statements 1 and 2 by the law of detachment or the law of syllogism. So let's talk about the one we have discussed in class. If it does, state which law was used. If it does not, write invalid. All right, look at what number 1 is telling us. If an E-STEM student scored 148 or higher on the Algebra 1 ACT end of course exam, then that student scored college ready for Algebra 1. All right, so here is an E-STEM student scored 148 or higher on the Algebra 1 ACT end of course exam. That's my hypothesis. My conclusion is that student scored college ready for Algebra 1. Well, my second statement says Bree got a 152 on the Algebra 1 ACT end of course exam. All right, so according to this, the hypothesis is true. It is true for an E-STEM student, Bree being the E-STEM student. And Bree scored college ready in Algebra 1. The conclusion matches that student scored college ready for Algebra 1. Matches. So I'm going to call this a valid argument. The statement 3 does follow 1 and 2. And that the law of detachment is the law we can use for that. Let's look at one more problem. Now, it says number 7 on it. Don't worry about that being number 7. Let's just look. If a marine animal is a starfish, then it lives in the intertidal zone of the ocean. The intertidal zone of the ocean is the least stable of the ocean zones. Okay, I want to think of this in if-then form. If you are in the intertidal zone, you are in the least stable of the ocean zones. Okay, I'm seeing if P then Q. This is being in the intertidal zone. So if Q, then R. If a marine animal is a starfish, P, then it lives in the least stable zone of the ocean, and that's the R. Okay, I think we're good here, guys. We are good to draw this conclusion from these two statements, but we did not use the law of detachment. The law of detachment is detaching the original. That's not what they did here. They used the law of syllogism. And we can discuss that further if you'd like. But email me your questions if you have any questions on the notes here. And I will see you Wednesday. Bye for now.